LG Institute of Pharmacy. Welcome to Pharma Ignite. In today's session, we are going to talk about histamine. So, in last session, we were talking about autocoids, introduction of autocoids, definition of autocoids, and classification of autocoids, right? So, let's have a quick revision of definition and classification of autocoids. So, autocoids are defined as a substance which are produced by variety of cells. Very first thing, they are produced by variety of cells. Second is, this substance are having intense biological response. And third is that this substance are produced locally and they produce their effect locally. Means they are produced locally as well as released in that site, in that area where they are produced. Right. So these three things are characteristic of an autocoid, which defines ultimately this whole autocoid term. Then after classification of autocoids, so autocoids are generally classified into three types. Very first is amine autocoid. Example of amine autocoids are histamine and 5-HT. Second is lipid derived autocoids. Example of lipid derived autocoids are prostaglandins, leukotrienes and platelet activating factor. And third is protein or peptide autocoids. Example of peptide autocoids are plasma kinase and angiotensin. So now in today's session we will talk about very first autocoid, that is histamine. Okay, so histamine means tissue amine. So histos means tissue and amine. So it is present in wide variety of tissues. That's why the name is given histamine, right? It is almost present in all animal tissues and in certain plants. The example of plant is stinging nettle. Its pharmacology was studied in detail by Dale in the beginning of 20th century. Close parallelism was noted between its action and the manifestation of certain allergic reactions. So the point is, when Dale studied the pharmacology of histamine, he found that the manifestation of allergic reaction and pharmacological action of histamine both are having close relationship, means both are almost same. In allergic reaction, ultimately there is vasodilation, there is extrusion of fluid, there is accumulation of fluid, there is accumulation of inflammatory cytokines. The same things are noted when histamine is injected and when pharmacology of histamine is noted. Right. Moving on, histamine was implicated as mediator of hypersensitivity and tissue injury reactions. It is known to play important physiological role. The physiological role of histamine is like it is acting as a neurotransmitter as well as it is playing important role in synthesis of our gastric acid. So these are physiological roles of histamine. We will see that in detail. Histamine is present mostly within storage granules of mast cells. So now the question arises, what is mast cell and what is histamine doing in the mast cell? So mast cells are our immunological cells which are produced by bone marrow. They are synthesized by pluripotent stem cells and matured under certain stem cell factors. These mast cells are having 50 to 200 granules inside it. These granules contains inflammatory cells, histamine, protease, heparin-like chemicals, right? So ultimately, this mast cell degranulation causes release of histamine, right? Tissues rich in histamine are skin, gastric and intestinal mucosa, lungs, liver and placenta. Non-mast cell histamine occurs in brain, epidermis, gastric mucosa and growing regions. Moving on, turnover of mast cell histamine is slow while that of non-mast cell histamine is fast. So now what is turnover? So turnover is ultimately synthesis, storage, release and metabolism. So synthesis, storage, release and metabolism of histamine which is present in mast cell is slow, while in non-mast cell histamine it is fast. Histamine is also present in blood, mostly body secretions, venom and pathological fluid. Now what is pathological fluid here? So pathological fluid means ultimately whenever there is an injury or there is an inflammation, there is accumulation of fluid and this fluid contains histamine, right? Now let's see synthesis, storage and destruction of histamine. So histamine is beta imidazolyl ethyl amine. This is structure of histamine. So this is our imidazole ring and this is the structure of ethyl amine. So that's why it is called beta imidazolyl ethyl amine. It is synthesized locally from the amino acid histidine and degraded rapidly by oxidation and methylation. So histamine is synthesized from histidine. Now what is histidine then? From where it is coming? So histidine is amino acid. It is semi-essential amino acid. Ultimately, children has to consume it from food and adult can synthesize it in body. So that's why it is semi-essential amino acid. It is having important role in protection of our myelin sheaths. So here is a process of synthesis and destruction of histamine. So very first is histamine is synthesized from histidine. So this is structure of histidine. So decarboxylase, in presence of this enzyme there is decarboxylation of histidine and ultimately it produces histamine. Very simple one-step reaction. Removal of this last carboxylic acid, that is by decarboxylase enzyme, and it produces simple structure of histamine. Now this histamine is metabolized by two enzymes. There are two reactions. Very first is by N-methyltransferase, right? So by N-methyltransferase it produces N-methylhistamine and this N-methylhistamine is further converted to methyl imidazolyl acetic acid by MAO, monoamine oxidase enzyme, and another is diamine oxidase. So diamine oxidase converts this histamine into imidazole acetic acid, right? So this is how our histamine is synthesized and destructed. Moving on, in mast cell, histamine, which is positively charged, is held by acidic protein or heparin. Now this acidic protein or heparin are negatively charged. So meaning is positively charged histamine is held by negatively charged protein or heparin within intracellular granules. When the granules are extruded by exocytosis, so whenever there is release of histamine, release of these granules outside of mast cell, right? What will happen? So sodium ion in extracellular fluid exchanges with histamine to release it free. So there is exchange of sodium with histamine ultimately. Here you can see this is example of a granule. So this is histamine which is positively charged. It is bound with protein which is negatively charged, or it can be bound with heparin too, which is once again negatively charged. Now what will happen? The sodium or calcium which are present in extracellular fluid which will exchange here ultimately. Sodium will take place of histamine and histamine is released in extracellular fluid. So moving on, increase in intracellular cyclic AMP inhibits histamine release. So whenever there is increase in intracellular cyclic AMP, now cyclic AMP is increased by many reactions or drugs inside the cell ultimately. So let's for example, beta and adrenergic antagonist, they may increase cyclic AMP inside the cell. Now this increased cyclic AMP will inhibit protein kinase C in the cell. Now this inhibition of protein kinase C will lead to inhibition of release of histamine granules from mast cell, right? Histamine is inactive orally because liver degrades all histamine that is absorbed from the intestine. Now mechanism of antigen-antibody reaction induced release of histamine from mast cell. So let's see how this histamine is released. So very first, let's see the structure of this antibody. So antibody is generally having two regions, right? This is the first region that is known as Fc region, or you call it fragment crystallizable region. Second is antigen antibody binding site. Yes, this both side there is antigen antibody binding site. This is antibody and antigen will bind here. That's why it is called antigen antibody binding site, or you call it antigen combining site. Both are ultimately same, right? So whenever there is entry of antigen inside the blood system, specific antibodies are synthesized. Let's say immunoglobulin E. Now this immunoglobulin E will bind on the surface of mast cell. So there are specific receptors called Fc epsilon receptor 1 present on mast cell where this immunoglobulin E will bind up. Now this immunoglobulin E will ultimately bind with antigen and induce reaction inside the cell. And that reaction is release of tyrosine protein kinase, TPRK, that stands for tyrosine protein kinase. This tyrosine protein kinase synthesized phospholipase C, and by that reaction ultimately there is conversion of PIP2 to IP3. Now PIP2 is phosphatidyl inositol biphosphate, and that is converted to IP3, that is inositol triphosphate, in presence of ultimately this reaction. So tyrosine protein kinase synthesized phospholipase C in presence of this conversion. So ultimately there is synthesis of IP3, and this IP3 causes release of calcium plus activation of protein kinase C. Both are required for release of this histamine. These are histamine granules present inside the mast cell. So whenever there is release of calcium and protein kinase C, ultimately they will cause exocytosis of these granules. Now as soon as these granules will come out, this will ultimately present in extracellular fluid. Now as we have seen that histamine is bound with negatively charged protein or heparin, so there is exchange of sodium or calcium with histamine, and histamine is set free in extracellular fluid. So this is how histamine is released. Moving on, histamine receptors. So 4 types of histaminergic receptors have been clearly defined and cloned. Analogues to adrenergic alpha and beta receptors, histaminergic receptors were classified by S. and Skill into H1 and H2 receptors. Those blocked by the available antihistaminics were labeled H1. So the receptor H1 was labeled by the blockers available in 1966. Sir James Black in 1972 produced the first H2 blocker, that is burimamide, and confirmed this classification. Till now, only these two receptors are clinically relevant. A third H3 receptor, which serves primarily as an autoreceptor controlling histamine release from neuron in the brain, was identified in 1983. Right? So this is H3 receptor is an autoreceptor. Now what is autoreceptor? So these autoreceptors are ultimately present on cell. Now whenever histamine will bind on this autoreceptor, it will inhibit release of histamine from the cell. So this kind of receptors are known as autoreceptors, which inhibit release of that specific autocoid or neurotransmitter. Right? None of the H3 agonist and antagonist has found any clinical application. Now these are three receptors, H1, H2 and H3, and properties of these three receptors. Let's see that. So very first is H1 receptor. So selective agonists for H1 receptor are 2-methylhistamine, 2-pyridyl ethylamine and 2-thiazoline ethylamine. Selective antagonists are mepyramine and chlorpheniramine. Receptor type is GPCR, GQ type of G protein coupled receptor. The pathway is IP3DAG, release of calcium from intracellular stores, as well as protein kinase C activation and nitric oxide release, which causes release of cyclic GMP. Right? Distribution in body and action mediated. So smooth muscle. So ultimately whenever there is release of histamine, and this histamine will bind on H1 receptor present on intestine, airway or uterus, it will cause contraction. As in asthma, what happens? Or as in allergic reaction, what happens? So there is release of histamine, and this histamine binds on H1 receptor present on airway, and it will cause contraction of airway. Right? Then after on blood vessels, so endothelium, very first is endothelium. Endothelium is ultimately cells which form these blood vessels. So endothelium, it releases nitric oxide and PgI2. PgI2 is your prostacyclin and ultimately causes vasodilation. Now remember this, vasodilation, it is produced in small blood vessels, means there is vasodilation of small blood vessels. Second is widening of gap junction, increased capillary permeability. Right? Ultimately, so let's take an example, that is bee bite. So whenever a bee or a mosquito bites, what will happen? There is release of histamine. This histamine will cause vasodilation. Then after widening of gap junction in blood vessels, and that is why the permeability of capillary is increased and large amount of fluid will come out from that area, and ultimately there is accumulation of fluid. So that is the reason that after bee bite there is accumulation of fluid. Third is smooth muscle of large vessels. It causes vasocontraction. So in large blood vessel it causes vasocontraction, while in small blood vessels it causes vasodilation. Efferent nerve endings are stimulated, ganglionic cell stimulation, and adrenal medulla releases catecholamines. Lastly, in brain it produces impulse, means repolarization and depolarization. So that is H1 receptor. Then after second is H2 receptor. Selective agonist is dimeprate and lampromidine. Selective antagonist is cimetidine and ranitidine. So to block ultimately gastric acid secretion, the cimetidine and ranitidine are widely used. Receptor type is once again G protein coupled receptor, GS type of ultimately GPCR. Effector pathway is adenyl cyclase activation, and by that increased cyclic AMP and phosphorylation of specific proteins. Action is gastric acid secretion. second is blood vessel dilation, and third is in heart it produces in atria there is positive chronotropic effect, means increase heart rate. In ventricles it produces positive inotropic effect, means increase force of contraction, and in uterus of rat it produces relaxation, and lastly in brain once again it produces impulses. Third and last one, that is H3 receptor. So examples for agonist are amethyl histamine and lametite. Selective antagonists for this are thiopyramide, lampromidine, tiprolestan and clobenpropate. Right. So once again remember that one compound, that is lampromidine, that is selective agonist for H2 receptor while antagonist for H3 receptor. Right. Now receptor type is H3 receptor is once again GPCR but inhibitory type of G protein coupled receptor. Effector pathway is restriction of calcium influx, potassium channel activation and decrease in cyclic AMP. Now H3 receptor is an autoreceptor, so that inhibits ultimately release of histamine. So let's see action of this H3 receptor. Lastly, there is H4 receptor. Now H4 receptor was found by molecular cloning, right? H4 receptor is present on eosinophils, basophils and mast cells, and it is having role in inflammation, right? Thank you everyone. Hope you like this video. Please like, share, subscribe our channel Pharma Ignite for more amazing videos. Thank you.